So far, the expressions on both sides of our equations have been fully simplified. What if we encounter an equation where that's not the case? For example, what if we encounter an equation that looks like this? This has a lot to it, right? The two expressions in my equation here, this one and this one, are not fully simplified. The way I'm going to approach an equation like this is to simplify each expression first. Now, I could simplify them both at the same time, just carrying along the equals sign between them, but I can also simplify them separately. And now remember, we're back to simplifying. We're working with just one expression, which means that there is no both sides to do anything to. We're limited to just the properties of arithmetic, the distributive property, the commutative property, and the associative property, to manipulate these expressions. So I've got my 3 times x plus negative 5. I'll use the distributive property here. That'll be 3x plus negative 15. That was my first expression. Done. My second expression, I have my 2x plus 1 plus negative 4 x plus 3. I'm going to use the distributive property on both of these sums, and I'll get 2x plus 2 times 1 is 2 plus negative 4x plus negative 4 times 3 is negative 12. And now I'm going to use the commutative property to rearrange this. 2x plus negative 4x plus 2 plus negative 12. 2x plus negative 4x is negative 2x. 2 plus negative 12 is negative 10. So that's my second expression simplified. The expression on the left simplified to 3x plus negative 15. The expression on the right simplified to negative 2x plus negative 10. Now this is an equation I know how to solve, right? I will add 2x to both sides. Here I'll have 3x plus 2x is 5x. Negative 2x plus positive 2x is just 0. So on the right, all I'm left with is negative 10. Let's see. Now I'll add positive 15 to both sides, and negative 15 plus positive 15 is 0, so I'm left with just 5x. Negative 10 plus positive 15 is 5. Finally, I'll multiply both sides by 1/5. 1/5 times 5x is just x. 1/5 times 5 is just 1. Okay, that's not so bad, right? We get x equals 1. To make sure that that worked, I'm going to check that in my original equation, not in any of the equations that I picked up along the way. Why? Well, because if I made a mistake anywhere in my simplifying process, I want to catch that when I check. 3 times 1 minus 5. That's going to be 3 times 1 minus 5 is negative 4. that's negative 12. 2 times 1 plus 1 minus 4 times 1 plus 3. That's going to be 2 times 2 minus 4 times 4, which is going to be 4 minus 16, also negative 12. Those are equal, so this was actually correct. Again, notice, I checked my solution in my original equation that I started out with, not in the simplified version, because I wanted my checking to catch if I'd made a mistake in simplifying.